All right, this is example 2 of our day 3 notes, and what this is talking about is the distance in feet of an object at a starting point. Now, the thing I want to point out right here is usually when we have an S sub t, it is what we call a position function. Okay, so the first thing we are asked to do is to find the average velocity from 3 seconds to 5 seconds. So if it asks us to find something between 2 points, we are basically still doing this. The function at the output at B minus the output at A, B minus A. So in this case, it asks us for 5 seconds and 3 seconds. And then we're doing the 5 minus the 3. We get 65 for the S sub 5, 43 for the S sub 3, divided by 2 gives us 11 feet per second. Now, the next question says, find the instantaneous velocity, which is the same thing as the instantaneous rate of change. And this time we want to find it at 3 seconds. So the other thing I want you guys to realize is when we have the limit, it is also what we call the derivative. So the first thing we are going to do is we are talking about how the function changes as it approaches 0. So this is where we are going to have that definition that we talked about a minute ago, where we have the change in the t, so the function, the t plus the change in t, minus the actual function. This is basically over the b minus a. So we have our t plus delta t minus t. And if you notice, the t and the minus t, those go to 0. So our function, if you recall, is 2t squared minus 5t plus 40. Wherever you see the t, that is where you are going to be putting the t delta t. So then if you go down to here, this is what we did right there. So we substituted the t plus delta t every time there was the variable t in the original function. So what does the rest of the definition tell us to do? It then tells us to subtract the original function. And all of that ends up being over the delta t. So, like I've talked about before, this right here, when you are simplifying or expanding, that is when you would do FOIL. So I'm hoping we feel comfortable with that. I think we've done FOIL for a lot of years in math. So we end up getting this t squared plus 2t delta t plus delta t squared. And we have that 2 on the outside. And then the function has us with that minus 5. And we are putting in that t delta t. The function has a 40. And then right here is when I change the signs of each of those by distributing that negative. So you're just changing those signs. And we have it over the delta t. Now, the next thing that happened is this was distributed. So we have the 2 right here. We have the 2t squared plus the 4t delta t plus the 2 delta t squared. We also distribute the 5, the negative 5. So we get negative 5t minus 5 delta t. And then we have that 40. So now when you look at this, what you will notice is the 2t squared and that minus 2t squared, those go to 0. The minus 5t and the plus 5t go to 0. The plus 40 and the minus 40 go to 0. We are left with this. 4t delta t plus 2 delta t squared minus 5 delta t all over delta t. Now, at this point, if you can see how the delta t simplifies with each term, you can totally do that right away. What I kind of like to do is to factor this out, factor the delta t, and then we are left with 4t plus 2 delta t minus 5, and then that delta t over delta t, that goes to 1. So we are left with 4t plus 2 delta t minus 5. Now, when we are actually taking that limit as it goes to 0, so we're plugging 0 in there, and all of that just ends up being 0. So what we are left with is 4t minus 5. So that is our limit as delta t. What this gives us is a function. So now we want to actually figure out the value at t is equal to 3. So you're just plugging that 3 in, 12 minus 5, and we get 7 feet per second. All right, so that is problem 2. And doing the average velocity and the instantaneous velocity, which is doing the limits and then plugging in that value that we wanted to find that for. If you have any questions, let me know. See you next time.